I'm Amber Habib. I'm convener of this conference, and let me welcome all of you to the opening of this, the third annual conference of the Mathematics Teachers Association India. In particular, I welcome the president of the MTA, its office bearers, its members, the conference organizers and volunteers, as well as our speakers, panelists, and all the participants. Let me also thank at the outset the Homi Bhabha Center for Science Education, which has generously lent its facilities to MTA in many ways, including the organization of this conference. MTA seeks to bring together mathematicians, teachers, educators, and the wider public in the cause of furthering interest in mathematics and improving its standards in India. Our annual conference aims to give a voice to teachers, create discussions around the larger issues facing us, and also raise awareness of resources and developments. This is the second time our conference has been forced to be held online due to the pandemic. Our situation here mirrors that of our schools and colleges. Much of our time will be devoted to this. Tomorrow, we shall have two sessions, one at school level and one at college, covering challenges, efforts, innovations, and the use of technology in facing the pandemic. Then on Sunday, we have a discussion on broader issues such as reopening of schools and coping with the effects of reduced teaching during the past year. Of course, we should not be completely consumed by the pandemic. We also must celebrate mathematics, the teaching of mathematics and mathematicians. And so we have three exciting keynote lectures by Jill Adler, Ken Ono, and Mahan Maharaj. And Philip Legner, founder of Mathagon, will conduct a workshop on learning mathematics with virtual manipulators. Since the online mode deprives us of the mingling and exchange of ideas over meals and walks that are essential benefits of a conference, and especially the one time that we managed to hold it at HPCSE, we must do the best with what opportunity we have. May I request you to participate as much as you can in the discussions and in the Q&A sessions following the talks. We will then finish on Sunday with the cultural program. I will soon hand over to Prof. Dani, the founder president of the association. After him, Harita Rawal, convener of the local organizing committee, will address some organizational issues, especially relating to the online nature of the conference. And then we will have our first event of the conference, the keynote lecture by Professor Jill Adler of the University of Witwatersrand, South Africa. Professor Dani, I yield the floor to you. So Dani is there?
Yeah.
Yeah, okay.
Sorry, there was a problem. I mean, somehow it took some time to open. So, welcome you all. It gives me a great pleasure to be inaugurating this conference as the president of the MTA, the Mathematics Teachers Association. The Mathematics Teachers Association was founded in 2018, is now 3 years old. As you know, in the society, there are various stakeholders who have a stake in the general improvement of standards of mathematics, our dear subject. Firstly, the large mathematics teachers community. There are mathematics educators who have taken it upon themselves to make an effort to improve the means of being able to educate. And then there are mathematicians themselves who are contributing to the subject. So a variety of stakeholders. So then the idea was that we bring together the various stakeholders with in a joint endeavor to improve the standards in through various activities, through interaction, by sharing ideas coming from various quarters and putting them into practice to the extent possible. Well, of course, for a variety of reasons, we have not been as successful as we would have liked to be in the optimism of the founding, but I think we have we at least created an ethos where this is now a real platform on which the activity can in fact be continued, and we can hope in the coming years to be successful in our endeavor to the objective which we mentioned, that it is that being to improve the standards at all levels, not just because there are agencies which are engaged in improving higher education, like the National Board for Higher Mathematics. Then there are teachers associations, and then there are, of course, where the teaching community itself. So of course we would like to involve and engage ourselves with all those who are concerned with the objective. And well, in the last 3 years, a few things have been achieved. This is in our, as you know, this is our third annual conference. The first one we had on 3rd January of 2019, which is the birthday of Savitribai Phule, the well-known educationist from India. From the last century. And then the second one we had, by the time we were to have the second one, the pandemic had set in, and I think a lot of things changed. Nevertheless, we had the second conference, which online, unlike the first one, which was a physical one, where we actually got together to discuss various things. The second one was online, and many of you may have actually participated in that, which was exactly about 1 year back, 5 and 6 September. And now we have the third one, and there's, as you see, even with the perhaps along with the change in the mode, it's both as it's limited. The new medium, online medium, has its own limitations as well as advantages. So, which we would like to take benefit of. So, it's a great pleasure to be inaugurating this. Let me also mention that Mathematics Teachers Association is also engaged in tries to generate interest in various other ways. One of the notable things that I should recall here is our publication activity. Hopefully all of you would have seen our bulletin, the Blackboard, and many interesting articles that you can find there from both in mathematics as well as mathematics education, and then various experimentations and so on. The whole spectrum of aspects of education are meant to be touched there. Many of them are touched there, and we look forward to have even more active publication platform that will support the other activities like conferences. And apart from the annual conferences, I should mention that we do mean to support a variety of conferences at many regional levels. This is one of the aspects in which the success has been somewhat, considerably limited than we had imagined it would be possible to. But as an activity, it has been there. It's as the bureaucrats say, the line is there, the continues. So next time you'll be filling in more into that. And then one of the general objective is of course, as you know, in generating interest. Establishing any kind of activity, it is kind of important that there be networking. And So we have had various membership drives and communications through that. So that of course a lot more needs to be done with regard to networking, but there's some beginning has been made, and I urge you all to get into the system, so to speak, that we are trying to evolve, and help us meet our objectives. I'll not spend more time trying to tell you more about the Teachers Association, which you can, of course, in our times, you can find out more about yourself once you have some developed some interest. And besides, I'm sure all of you would be keen on getting into the conference mode. So I should I'll conclude now. Let me conclude with my hearty welcome to Professor Jill Adler, our first keynote speaker, who is here and will soon be giving her keynote address. Before that, I'd like to invite Harita to introduce you to certain various aspects of the conference that she would like to, and maybe some of the things that you should bear in mind. So over to Harita.
Good evening, everyone. We hope that we could do this conference this time on an offline mode, but as time has gone for the online thing, there are some things that I would like you to take care while joining the session. Please do not switch on and switch off your video cameras during the session. You can post your questions to the Zoom chat or else to the Zoom manager. You can see in the participation list, there is a person called Zoom manager. You can directly message to that person as well. We will start all our sessions on time. So please join us on time. And we request you to avoid any kind of touching any buttons or unmuting yourself or starting a video in between the talks. We request you to kindly keep the session for the speaker as well. The general body meeting will be only available to the members of MTA. So if you are a member, you have already received an email from the MTA office. Thank you, and hope to see you on the group photo day 3. Over to you, Kees.
Hello. Yeah, now we are ready to for the keynote address of Professor Jill Adler. Let me first introduce the person who is going to chair, and it's none other than Professor K. Subramanian, also known as Ravi. Ravi needs no introduction to this large gathering, I'm sure. He just recently retired as the director of the Homi Bhabha Center for Science Education, which has been one of the key institutions involved in mathematics education, and in particular has been one of the major supporting or institutions for the Mathematics Teachers Association. And Ravi himself has been one of the moving spirits since the foundation of the Mathematics Teachers Association and its activities and so on. So it is very much in the fitness of things that he chairs the inaugural session of Professor Jill Adler. Over to Ravi.
Thank you, Professor Dani. Am I audible? I'm not able to switch on my video for some reason. So perhaps the host can do something about it.
Audio is fine.
Audio is fine, okay. So we'll have the audio till perhaps the video gets switched on. Thank you for the introduction, Professor Dani, and a very warm welcome to everyone to the conference and to the first session, which is the keynote talk by Professor Jill Adler. Okay, I think now I'm able to open my video. Thanks. It gives me great pleasure to introduce Professor Jill Adler. She is a professor of mathematics education in the School of Education at the University of Witwatersrand, also known as the Wits University in Johannesburg, South Africa. She's also a visiting professor of mathematics education at King's College in London. She has been the president of the main body overseeing the mathematics education activity around the world, the International Commission on Mathematics Instruction, ICMAI as it's called. She was the president, recently stepped down. And she's, of course, very well known as a leading researcher in mathematics education. She has received a number of awards, the most prestigious of which is the top award in mathematics education research called the Hans Freudenthal Medal, which she received in 2015 in recognition of a research program. Jill is what has been described as an engaged scholar. She's not merely a researcher, but a true leader in the field. It may interest many of you to know that she started her career, I believe, as a teacher of mathematics. She has also been a developer of materials, a teacher educator, and a researcher. She has been a spokesman of sorts for pushing the agenda of mathematics education from the perspective of the developing world, which, as you know, faces different kinds of problems from that of the developed world. And she has brought these issues to the forefront, notably her research in multilingual cultures and multilingual classrooms, which is typical in many countries in the developing world, including in South Africa. She's also worked a great deal on the sort of knowledge that teachers need to have, specialized knowledge and specialized capacities to teach effectively, and again, from the perspective of a developing world context. It's a matter of great pride for us that she's associated with the Maths Teacher Association as a member of the advisory board. And it's a great privilege to have you here today, Jill, to give the opening talk for the third conference. And thank you very much for making it possible, despite we know you're in a sort of difficult period. And thank you for making it. And yeah, over to you, Jill.
Thank you, Ravi.
Before you start, Jill, I think the talk will be for about 45 minutes. I'll tell Jill at the 30-minute point. I'll give her an indication. Please put in your questions in the chat box. The questions will be taken up after the talk. And in case you have any difficulty doing so, or you would like to speak, please raise your hand. And then I or one of the co-hosts will allow you, unmute you and allow you to speak. Yeah. Thank you. Sorry for that, Jill. Go over to you.
Thank you, Ravi. And thank you to the Teachers Association for this honor and invitation. One of the affordances of the difficult time we live in is that it is possible to be able to speak almost as if we're in the same room, but we're not, very far away. But it feels like, and as I look who's online, I see a lot of my friends from the Homi Bhabha Center and others in India. So it's a great privilege for me to be here and be able to talk today. So I'm going to share screen quickly and introduce the talk. So while it is extraordinary times and schools here, like I would imagine many schools in India have been significantly affected by the pandemic. We've had, I think the figures here are something like 50 to 70, that many of our children have lost 50 to 70% of teaching time for the past year. I don't know what it means to say lost, but this is the conditions we deal with, and teachers are dealing with as they try and come back to schools now. But I'm not going to be focusing on the pandemic as such. I'm going to be talking about some key work that's come out of the Professional Development Project. It's a research and development project I've worked in for the past 10 years, and I'm going to be talking about some of the practices in the project that I hope the audience will find interesting for your own work, for your own teaching, and in teacher education. So the title of the talk is Exemplifying and Explanatory Communication. And what I'm going to be trying to show is that these are two key tasks of teaching. They've been built into a framework that we use in our project for working on teaching, and I hope to be able to share some of this work with you, as I said. So to get started, if I was in the room, I would make everybody do this and then raise hands and have some discussion, but that's not possible. So I'll try and think about what you're thinking. So I want you to think about a maths lesson, starting to prepare a maths lesson. And some of what I imagine you would do first is think about, well, I need to set some tasks. I've got to have something for the learners to do, for the students to do. But of course, if they're going to be tasks, I would need to think about what's the examples or the example set in the tasks. What are the kinds of things they've got, the kinds of mathematics they're going to be working on? How will I represent this? And just to give you some sort of idea to think about it, here are two very different kinds of tasks. So the one is, are these equations sometimes, always, or never true? Explain how you figured this out. And there are three selected, we can't do this unless there's some equations and some algebraic objects to think about. A very different kind of task, which also leads to an algebraic equation, is there's a rectangular field, its length is twice as long as its breadth. If its perimeter is 240, find its length and breadth. Explain how you figured out your answers. Now I've highlighted in red, what are the key things that would make up this example? You would get a very specific equation coming out of this for a problem around area and perimeter that you could represent diagrammatically, symbolically, and so on. So in working with examples, tasks, and representations, our work has talked about these being key components of what we would call a key task of teaching called exemplification. Any lesson has to exemplify the objects that it's trying to get learners to come to know. I see a hand up. Is this for me? I don't know what the hand up is for. Should I just ignore it?
Yeah, let me find out from the person, Jill. So I suggest you continue, and if there's anything, then
okay.
Yeah.
Thank you very much. I was just worried maybe the sound wasn't clear or something.
It's very clear.
Okay, so we talk about exemplification as being a key task of teaching, key piece of the work of teaching for which you need specialized knowledge. And we work on exemplification with teachers in our project. Now, exemplification this is something teachers do, you do every day, but doing this well is not trivial. And it actually requires deliberate work and key elements of knowledge, as I hope I'll be able to show. In addition, and I think as is shown particularly in this example, though it's in both, is that it's not only about what's exemplified, it's also about how it's communicated. And to communicate, we use words, we use specific mathematical words, we use specific mathematics ways of speaking is something always, sometimes, or never true. And so this is another key task of teaching, and we work on both of these in our project. So this is the focus of my talk today: exemplification and explanatory communication as key tasks of teaching. These have been key areas of research in maths education and the work of our project. We've also done research on this, and I want to be able to argue with you today that this research and our own work does show that working on exemplification, particularly using principles of variation, creates rich opportunities for learning. And of course, I'm going to explain what I mean by principles of variation. In addition, working on explanatory communication, and what we mean by that is working with teachers on explicit language practices. Now, I'll show you that this is important anywhere in the world. It's particularly crucial in multilingual contexts and where not all learners are fluent in the language of instruction. And so paying particular attention to word use, notation, and ways of arguing mathematically, so justifying, these further enrich opportunities for learning. What we've done is combine that into a framework that we've developed for describing and working on mathematics teaching. We call it the Maths Discourse in Instruction Framework. I'm not quite sure exactly where the name originated from originally, but you can see because we pay attention to explanatory communication, we certainly focused on discursive work. But what the framework says is that to plan any lesson, you have to have a lesson goal. There's always a lesson goal, and that is something that you want learners to come to know and be able to do. We call that the object of learning. And in order for that to be learned, it would have to be exemplified and then communicated. And of course, learners need to participate in these practices. What I've explained very briefly and shown very briefly is that exemplification is a combination of particular examples, the tasks that are associated with them, and how they're represented. And explanatory communication is made up of many things, but specifically of how we use words and how we justify. And I worked together with a postdoc when she was with me. She was a postdoc. I see she's online, Elena Ronda. And we've written up this framework, how we use it as an analytic tool, and people might want to look at that. I'm not going to talk about this in any more detail. I'm going to now zoom in. But before I do that, I forgot about these little arrows, is to show that as I talk now, of course, when you're planning and when you're thinking about teaching, you need to start with what it is you're trying to do, what it is you want learners to learn, and then you exemplify, communicate, you think about how you exemplify and communicate. So you move in this direction. But it's as important to say, well, if these are the things that are happening in the lesson, and we call them the mediational means, actually, are they enabling learners to learn what it is you wanted them to learn? So this is the framework. We have a teaching version of it, illustrate that later, that we work on with teachers, but this is the conceptual framework that we work with. And I'm going to start now with looking in more detail at exemplification and principles of variation. First, I want to look at the literature, at maths education research. It's a big field now, actually, exemplification in relation to variation and variation itself, as I'll show you. And I'm going to draw on some of that work. So first and key, and they have been very pivotal in our work, is the work of Anne Watson and John Mason. So you'll see this came out in 2007, and they started talking about, they were linked in to the work of Swedish researchers, Ferenc Martin, who developed variation theory, but they attuned it towards mathematics and saying that exploring that variation and invariance, and particularly with example sets and sets of exercises, can engage learners in what they were talking about then in mathematical structure, and that's really important. It's very interesting to look now, 2019, here is a very recent publication of which Anne is one of the authors, because in the UK, they've been working with teachers in Shanghai. It's been a long collaboration on bringing principles of variation into teaching in the UK. And this particular paper, they look at how using variation with example sets actually creates opportunities for learning. But of course, it's not only the UK. Here's an interesting book for people that are interested, Teaching and Learning Mathematics Through Variation. This was published just a few years ago, and it brings the practices and traditions both of the East and the West together. So variation has been used extensively in China, and those of you who were at the ICME Congress and listened to the plenary by the Chinese researcher. He'd been researching in Shanghai for 45 years and explained how attention to variation was very, very important in improving the quality of teaching, and particularly conceptual teaching in China. So there's been a great deal of work there. There's been a great deal of work in Sweden, and so all over the world. But it is the work of Anne and John Anne Watson and John Mason that has particularly influenced our thinking. And of course, we've been able to contextualize it for our own work in South Africa. And so that's what I'm going to turn to now. Oh, before I turn to that, let me just show you some of the examples, because it brings out some of the principles of variation. So this is an example in that 2019 paper of a teacher who's teaching about right angles. And you can see the task for learners. It's an example set. And what these are examples of angles, some of which are 90 degrees or look like they're right angles. Some of them clearly aren't. And so the task is which ones are the odd ones out and why. Now, there could be a number of ways you could look at it. You could look at the length of the sides, but where the teacher would steer this would be is that some of them are corners, some of them are 90 degrees, some of them aren't. And this is what it means to have an example set where you bring out contrast. You're able to show what a right angle is by putting it next to angles that are not right angles. If you only look at corners, it's very hard to see what's not a corner. And so contrast is about what it's not. And this is one of the key principles of variation. Here's another example. Here's the task. Divide. You can see I'm talking about an example set and the task with it at the same time. Divide 60, and here are 4 different ratio tasks: 1 to 1, 1 to 2, 1 to 3, 1 to 4. Now, this could be a simple exercise on practicing how to calculate ratios and parts. But actually, if you add to it, well, what patterns do you see? You could generalize about the ratio, the size of the ratio, and what's happening to the numbers in the ratio. And it's through this kind of similar pattern that you're able to build generality. And in their work and in the work that we do focus on similarity, and so leading to generalization, which is really important in mathematics, and bringing out contrast to being able to see a class of objects and what's not part of the class of objects. And one of the key things that I'll demonstrate later is why contrast is so important, is that it actually can work to when learners are overgeneralizing. So that's what they do when they go beyond the class of objects to which a property applies. And then contrast is very important. So here's another example, which is less about similarity and contrast, but more about actually thinking mathematically. So here are some identities. Can you predict the next? And this is important ways of thinking mathematically, being able to write this and then think about what would be the next identity. And the next one coming is something different. Here are just 3 relationships. And if you look at what's the same and what's different here, the only thing that's changing is the relational sign. And it helps think about not just the procedures for solving equations and inequalities, but what is the difference between them? And so also understanding the structure of these expressions. And so what I've tried to show with these examples is how they have worked, Watson and Mason, with generality and structure as very important in mathematics, and how variation can be used to enable rich learning towards these. And there they are, the 3 important things that I've just mentioned. So now I'm going to look at the Wits Maths Connect Secondary Professional Development Project, big acronym for a long set of words, and how we use variation and example sets and their relation tasks. I'm just going to give you some examples of the kinds of things we do with teachers and with different purposes. So here we would be wanting to work with teachers to understand that if variation can be used very productively, if you want to enable learners to make a move to understand that the equal sign is a relational sign. So here is a set of examples. You can see them, they're all numerical equations. The task here is, are these true or false? So it's not just a calculational task, it's to say whether these are true or false. And there's something very important we could look at here. I've said it's an example set and related task. And these are the questions that we would want our teachers to think about and ask, is what's varying and what's invariant? Now it's very clear to see that this is invariant, but what is varying is the right-hand side of these equations. And so what is possible to learn through this example set and the way variation is structured here? So the first thing to learn is that it enables a shift in focus, which anybody who's taught lower down in the school would know that sometimes it takes learners a long time to shift from 4 plus 6 makes 10 to an equivalence relation. 4 plus 6 is the same as, or has the same value as 10. And this example is a key example that shifts focus from gives me to is the same as. So the initial focus is the answer. The answer is 10. The new focus is, are these equivalent? Are both sides equal to 10? Here's one I slipped in here to say, is this stable? Because if it's not a stable idea yet, learners might be seduced into thinking 4 plus 6 is equal to 10, so therefore this is true. And that would be one way of picking up whether this shift is stable. And of course, if you want to increase the demand of the task, you could introduce these equations that bring in the order of operations. So that's to give you one idea of how we work with equations to bring out principles of variation and for the teaching of a new concept or an important change in learner thinking that needs to happen. So here's another one. Very different task, also a set of equations. Solve for x, what's varying, what's invariant, what's possible to learn here. Well, again, we've got the left-hand side is invariant, and what's changing is the right-hand side. Now, these would each need to be solved and an answer obtained, but that's not sufficient to carry out those procedures. The task is also to be able to say, can you see sometimes you'll get one solution, sometimes you'll have no solution, and sometimes you'll see an equation that is true for all values of the variable. And this is a particularly important property of equations. Equations are sometimes, linear equations are sometimes true, never true, and always true. So what I've tried to show here with these examples and using example sets and tasks is that if one is working with principles of variation amidst invariance, and so looking for similarity and difference, you can make key features of mathematical objects and mathematical procedures and processes visible and create possibilities for generalizing. If you use contrast, you can also show instances of what the concept or procedure is not through a counterexample, a non-example. And I hope what was also visible to you is that constructing these example sets is not a trivial task. They need careful construction and thought. But for the purposes of learning, these are small example sets. Each of them was small, and each of them had a key learning object that was possible to learn, that made possible or made available the particular concept or process you were thinking about or wanting learners to learn. And of course, they were tied up with different tasks depending on what you wanted them to focus on in the example set. Here is an example that's not about working with our teachers so that they can use this in their classrooms. This is one where we're working with teachers themselves on strengthening their mathematical knowledge. And so when we do this kind of teaching, we ourselves pay attention to variation. And so I've talked about, called this using variation in teacher education, in our own teaching of mathematics in teacher education. Here, where you can see we are modeling principles of variation and connecting different representations. And this is a very important task because for the teachers that we're working with in our project, I didn't mention this earlier, but they're mainly teaching in the lower secondary and we're working to strengthen their mathematics. And so they would not all be fluent in mathematics in the senior secondary. And so we want to introduce them to unfamiliar mathematics as well as revisit the mathematics they need to teach in school. And here we work with what for them would be, in their professional development work, relatively unfamiliar functions. They might have seen this in some of their undergraduate training, but in our context, many of the teachers working in the lower secondary school have not had access to higher levels of mathematics. And so this would be, or they're teaching out of, we would call it teaching out of field. They're not trained mathematically and are teaching in this at these levels. And this is a way of working with teachers. This particular example and the way it's structured actually enables you to bring into focus domain and range. You can see here that there is the upper and lower bounds on the domains and range. And these functions, as opposed to working with them on the linear function or the quadratic function that they will be teaching in those grades, this particular function brings these concepts and notions out much more clearly, and it works very well if you yourself are planning these using principles of variation. Now I want to talk with you very briefly how our teachers have used these principles in their own work. One of the small projects that we did was lesson study. Now, I don't know how many of you know about lesson study. It's a very well-known professional development activity emerging initially from Japan, though many in China would say they've been using lesson study just as long as the Japanese have. But Japanese lesson study is very well known across the world and has been very influential across the world. And its raison d'etre is to say that actually teachers should study their work, they teach lessons, you study lessons to improve your practice. Lesson study in Japan takes place during the school term. It's built into teachers' professional work. It's really systemic. It's part of the culture in Japan. This is certainly not the case in South Africa. And so introducing this and having our teachers work with it meant we needed to work on our own model. But we wanted teachers to be able to study and talk about their practice. And so we worked with them in small groups, clusters of schools in small groups on a problem that they identified. This is just one example. And this was the problem they identified. The students in their grades, be they grade 8, 9, or even 10, they were saying to us, were making prevalent errors when they were working on expressions with brackets. So there are some of the errors you can see. You can see conjoining, you can see overgeneralizing. These are the kinds of rules that are operating. Do what's in the bracket first. So we first add the 4 and the p, we conjoin. Then we say 2p minus 4p gives me negative 2p. It could be brackets mean multiply, so I'm going to multiply, and then sometimes they'll say negative 2p times 4, negative 2p times p. Here it was 2p times 4 and 2p, somewhere the negative came in, times p. And so it's reliance on shortcuts, rules without rationales, overgeneralizing. And what the teacher set out to do was actually plan a lesson that would work with learners on simplifying algebraic expressions with brackets in different positions. So using principles of variation, using the framework that we work with to see if they could enable their learners to learn. I'm not going to go into a whole lot of detail about the study, but just give you an idea of what the teachers planned. So this is, and how we worked it. This is the model very briefly. Teachers work together, they plan, then one teacher teaches the lesson to a group of learners, then the teachers get together after the lesson and reflect on it and replan the same lesson. A different teacher would teach the same lesson to a different group, and then there would be reflection again. And of course, it could plan again and lead to the same lesson a third time or a different lesson. This is how we worked with these teachers. We worked with them after school, just once a week, because we couldn't work during school time. We worked with them on either a key concept or particular learner difficulties, like I've exemplified here, or it could be a teaching difficulty. And we worked with them with the framework. And so principles of variation in setting up example sets, paying attention to how you use words. There's the framework as we work with it in teaching. There's the exemplification made up of tasks and representations and example sets. And if we work on these carefully, we can help learners to build generality, see generality and structure through variation amidst invariance. We would also be thinking importantly of, well, what are the learners doing? Who is doing the maths? Who is talking the maths? We have very traditional teaching in many of our schools. And so it's very important to be thinking about who's doing the talking and who's doing the thinking. And of course, we would pay attention to, as I explained right at the beginning, explanatory communication. But I'm going to focus in here, on the example set, because this is what was really interesting through this lesson study. So this was the lesson goal for the teachers. They wanted learners to become more flexible, fluent, and less error-prone in simplifying expressions with brackets, and when the brackets were in different positions. And so I'm not going to give you the whole lesson, but here is the introductory example set, and this was the third activity. You can see they introduced the lesson by working with numerical examples, so starting with what the learners knew and were more familiar with, and then moving on to algebraic examples. You can see what's variant and what's invariant in both these example sets. The task for learners was first to simplify on their own and then compare and discuss their answers with their neighbor, their partner. And this way they would see if they were making errors. And then the teacher worked with them is, what do you see as the same and difference in each of these? What do you see as the same and different in each of these and the answers that you're obtaining? So we get the same numbers and terms, but the brackets are in different positions, and these change the calculations and the simplifications. So the first teacher taught the lesson that had been jointly planned. And at the reflection, Tembi was the teacher. And she said, do you remember activity 3? She was reflecting because we asked her to think first about what she thought about the lesson. She said, by the time I got to activity 3, they all answered, yes, it will make a difference. They all answered that they could see that the position of the bracket made a difference to their solution and to their calculation. So in other words, she said, but for me, it was not enough. And what she was saying as we probed a little bit further is that she thought the lesson was too easy. So we then started talking as a research group, working with her and other teachers is, well, what could we do to make the lesson more challenging? And one of the researchers in the group said, I've got another suggestion. What if you give them the answer and then said, where must we put the brackets to get this answer? So those of you that know John Mason's work, this is also about doing and undoing. So often in mathematics, we just get them to multiply out or remove the brackets. What about the other direction is undoing this and putting the brackets in? And Tembi said, oh, is that where you give them the x minus 3, x plus 5, but then give them the solution and ask them, where should we put the brackets? I think that's a brilliant idea, she said. So together, we planned the new activity. Insert the brackets into the expression. And now we created this quite carefully. You can see here, we have the same trinomials. We have different results here. So where are we going to insert the brackets into each of these to get these results? And it's not a trivial task. It was lifted the cognitive demand of the lesson. A small change in the task increased the cognitive demand. The next lesson was taught by a second teacher. It was very interesting. The learners were very challenged with this, and the doing and undoing was really an important learning for both the teachers and the learners.
30 minutes.
30 minutes. Okay, thank you. So what Tembi said at the end when we were reflecting and we were doing the research is, and she was talking actually with the other teachers, is what I've learned from these is not only about my teaching and the strategies, but I've learned more about the mathematics behind everything. And the reflection helped a lot, especially looking at the examples. We've grown a lot by looking at the examples and example sets. And of course, what she didn't mention then, but the way we looked at those was through principles of variation. So in the next few minutes, I want to now move off variation and exemplification and onto explanatory communication. And so spend a little bit of time looking with you at how then do we work on explicit language practices, and particularly then issues of word use, notation, and ways of justifying such that they enrich opportunities for learning. And here I'm going to look at tasks that we do with teachers. Before I do that, just a word on the literature again, and this is for people who might want to go into the maths research literature. It's not so easy to see here, but what we've got here are two publications. This is by Nuria Planas from Spain, who's very well known for her research on multilingual teaching and learning in Spain with Catalan and Spanish. She's done a huge amount of work there, and on language as a resource for teaching and learning. And this is Suzanne Prediger, who's running a big project in Germany. And what both of them are arguing for, and these are quite recent, these publications, you'll see 2019, you can't really see it here, 2020, is working on language responsive teaching and saying, actually, teacher talk and communication of conceptual meaning is crucial. What they're also saying in these papers, and that's been very important for us in our project, is that this takes deliberate work, and it is very specialized knowledge of teaching to understand what these language practices are and how you would work on them. Those of you that would know the field would know, in fact, that much of the work on language practices in multilingual classrooms actually does emerge out of South Africa. A lot of work was done here, and a lot of the work on being explicit with language practices came from multilingual classrooms. What I wrote in this recent paper is that so they were talking here that content is very important, that language practices are content specific. You can see here in Nuria's paper, she's actually asking, if you've got language as a resource, how specific does it need to be? And she actually argues in this paper, she's arguing about equality and equivalence, and the way teachers use and talk about equality and equivalence when solving equations is very important if the relational notion of the equal sign is to emerge, and the transformations in solving an equation are to be understood. Suzanne is working she was working with probability, she was working with a number of different content areas, but has also argued in all of her research that there are specific ways of using language that is specific to the content that you're teaching. And so these kinds of content-focused language practices are very important. What I added to in this paper and through our research is to say it's yes, language practices do need to be content specific, but they also need to be context specific. And what I mean by that is the language practices we're working with, some of the things that we're focusing on here are specific to some of the issues that we were dealing with our teachers in relation to teaching particular contents. And I hope I'm going to illustrate those. And perhaps this would be the same in India. You might not find the same problems, but there would be, I'm sure there would be some that are specific to India and the way people speak English perhaps and speak mathematical English. So one of the things we start with our teachers is to show them the curriculum statement. There's no need to go through all of this, but this is the curriculum statement that if they're working in grades 7 to 9 in the junior secondary, the curriculum statement emphasizes the language of mathematics, how important it is to be able to communicate and reason. And to do that, you have to talk, to be able to represent information. And so what we talk with them about, if these are curriculum goals, then learners need opportunity to do and learn these skills. And so as teachers need to learn ways and what the knowledge is involved in this for them to support learners in this learning. So I'm going to start with one task that I'm sure you'll find very interesting. I hope so. But here is it's come up in a number of research places because it's been an interesting phenomenon in how learners actually respond to this calculation. Calculate, if you want to say -7 plus 4, -7 add 4, whichever words you want to use, and explain your answer. That's the task that they were given. And in this particular work that I'm referring to, and we constructed this for our teachers, 5 learners all wrote the answer -3. So everybody gets the right answer, but their explanations were different. And what we're trying to do here is to work with teachers on what makes a good explanation, what makes a full explanation, what makes it more mathematical. And what we wanted to understand from them is which of the explanations did they value as teachers, and could they justify why they valued them? So here are the 5 explanations. And this is the one that I know many people in other contexts find strange, but actually we would find it across our schools. So you get -3 because when you work with the numbers with different signs, you take the smaller number from the bigger number, and then you put the sign of the bigger number. So 7 is the bigger number. So 7 take away 4 is 3. And because it's -7, you get -3. Now it's a mouthful, but I think if you think about that for a minute, you'll see actually it will always get you the right answer when you're adding numbers with different signs. But there are a number of things that I think you will agree is quite problematic in the way that's being thought. And then there would be others that perhaps would be more typical elsewhere as well. Well, I get -3 because I have -7 and +4. So I've got 4 minuses and they cancel with 4 pluses and I'm left with -3. Okay, so there's a routine, there's a procedure, there's a rule that's being followed here. Both of these are rules that are being followed. The second one has a bit more mathematical integrity. Here's one that relies on everyday experience. I owe 7, I pay back 4, so now I only owe 3, which is an interesting way of being able to represent this, this expression. So you get -3 because now has an image, the student has an image of the number line. If you start at -7 on the number line and jump 4 places to the right, because you're adding, you land on -3. And perhaps the last one, you get -3 because I'm adding +4 to -7. +4 added to -7 is 0. So mathematical properties and principles guiding this response, leaving me with -3. So a couple of things I want to point out that we would work with teachers on this is that although this gets the right answer, you get the right answer every time. The real problem with this from a teaching point of view is that the learners are still working with the discourse of whole numbers. They haven't yet moved to a discourse of integers. And that's very problematic because one of these things is to be able to start to work with integers. Here you start to see the move and the shift. to a discourse of integers. So we would work with teachers on what does it mean to use words for working with integers. What are the important things to be thinking about? One of the things we spend quite a lot of time on is that the difficulty if the only word used for the negative or subtract sign is the same one and it's minus, then distinguishing between the sign and the operation will become difficult for learners. So teachers need to distinguish subtract, the operation, from negative, the sign. And so teach themselves not to use minus, minus, minus every time they work, and make sure they introduce the learners to being able to distinguish between sign and operation. Talking about bigger and smaller numbers is problematic when you drop the sign. -7, the 7 isn't bigger. So all of those things we would work with. Jumping places is fine, but what does it mean? And of course, cancel, we would know, is a very well-used, popular maths education word in schools, but it has a number of different meanings. So we need to be thinking of those and thinking of when we're using these as labels rather than with meaning. If we are using colloquial and everyday words, do they carry the integrity of mathematics? Are they helping build towards mathematical ways of speaking? And are we introducing mathematical words because the learners need to enter the discourse here of integers? And of course, we would want to move justifications from rule-based discourse of whole numbers, using real-world examples and visual representations, but to a discourse of integers, which has much more mathematical generality. Sorry, I jumped quickly to the next one. So that's one example. I'm going to move on to another one just to try and reinforce these messages. Here is another task we work with teachers on, and this is a very, very common learner error. It's known everywhere, but it was prevalent conjoining. Grade learners know that these are unlike terms, grade 9 learners. They will be able to say we can add like terms, we cannot add unlike terms, but they will still conjoin. So here was the task for teachers: convince a learner that he or she is wrong or in error, depending on how you would want to deal with error and the language you would want to work with here, or convince the learner that their way of thinking is not true in all cases. Write down at least 2 different ways that you would do this. And in your group, collect, this is what we would get them to do, collect the different ways of explaining, and again, figure out for yourselves which you think is the most convincing and write it up in poster form. And this is where context matters, and I hope I'm going to be able to illustrate that. So when we work on a task like this with teachers, we have some principles that we work to design these kinds of tasks. First of all, there must be a clear learner task, and it must be recognizable for the teachers. So this is a very well-known task, a very well-known error for the teachers, and it's a fairly straightforward task. It's a well-known error in early algebra learning. We get the teachers to externalize their thinking so that when we're working in teacher education, we can see how the teachers themselves are thinking about what counts as an explanation in their classrooms. And then we work with them to establish criteria for what we would call valued knowledge, valued mathematical knowledge, or the mathematical knowledge of the mathematical community. So I'm going to show you very quickly some of the responses that we get from teachers. So here, I hope it's big enough. You can see we've got 5p represents oranges and 4 represents 4 loaves of bread. We can't add them. Similar one here in another group for sweets, chocolates, sweets. We can't add chocolates and sweets. Here is one that is quite different from those two. You can see these two are our attempts to locate these in everyday practices. You would also see this if you know this work in algebra, that it's the the unknown is an object, the letter is object, so A is apples, B is bananas, P is pencils, as opposed to a variable. But here, this group of teachers actually does go through P is a variable, and so tries out different numbers and finds that in fact the equation can be true, but only if P is 1. So it's not always true. And here, this group actually does a number of different ones. So actually, what was interesting about this group is they also do 5, P, and 4 are unlike terms, so you can't add them. Then they do left-hand side, right-hand side, and also say something like 4 is an absolute number, whereas 5P is a product of a coefficient, they say, with a variable P. Over the 3 years when we've worked on this with different groups of teachers, we were very surprised to see, and this is why context matters, as I say, that this was the most prevalent and the most valued response. Okay, and the teachers argue quite vehemently with us that this works. Okay, it actually, fruit salad algebra, which is what it's called. So you can't add A and B because they're unlike terms, because A stands for apple and B stands for bananas. So you can't add them. It's very well known area in the algebra research. And many teachers argue and argued with us in the sessions that this is the way to do it, because actually it does prevent errors while they're teaching this. Here we would see is a full explanation. And here we see teachers who can not only give a full explanation, but also a range of justifications. And we would then go on with teachers again to look at the words that we use with this, like terms, variable, unknown, who is using those words, why do we need to use them? This is about variable, actually. This whole task is about the notion of a variable. We would also might be referring to the constant number, the coefficient, and to operations. And so we are using mathematical language, mathematical words, as we're building explanations. We're also using reasoning, if, then, always, only, and we would talk with them about what else might be ways of speaking. And we would talk with them about when colloquial and everyday language might be problematic. So some of the language that we picked up is 4 is not like 5x because it has no variable. 5x or 5p is a different number because it has a number next to the variable. And these are visual cues rather than the meaning of the algebraic symbols. And so we would work with teachers on that. And then we would work with them on what are these different kinds of explanations. So we would focus on this because it's so prevalent. And as I said, we would have very, very robust conversations with teachers and arguments with teachers about what works and what's mathematical and what's important then for teaching and for performance. And so in order to deal with that, we then also offer a replacement. If you do want to work with this and work with the expression 5p plus 4, is there another way that we might do this that would link with learners' everyday realities? And so rather replace P not with pencils, but with a number of sweets. So introduce the notion that P stands for a number. And then we would talk about, you could just try a few cases and then you can have a much more general explanation that draws on mathematical properties. So what I've tried to show you there is how we work with our framework. There's always an object of learning, what learners are to come to know and be able to do. And what's the knowledge that teachers need if they're going to be able to exemplify well and use language practices well in their classrooms? Here we argue this is about building principles of variation, thinking about the example sets and the related tasks, and where appropriate, what representations you're going to use. And these language practices being very important in our classrooms, and the teachers need to pay attention to that as they plan, and they need to think back. Having done these things, did they provide opportunities for learning? So to conclude, I want to make just a few very, very quick statements about, so we've done all of this, but did anybody learn anything? And so I could have spent the whole presentation talking about the project and its results, because the project was a research and development project. But I rather, for this conference, wanted to focus on our practices. What did we do around these key tasks of teaching, exemplifying and explanatory communication? But our if you like, our, what's it called? Our, forget the word now, but our hypothesis, our what do you call it? Action, theory of action. Our theory of action was that if, not theory of action, I'm sorry, I'm having a moment here. But this was what our hypothesis was, that if we worked with teachers on their specialized knowledge, and that's both mathematical knowledge and maths teaching knowledge. Some people would call this subject matter knowledge and pedagogic content knowledge. We talk about it as the mathematical knowledge and the maths teaching knowledge. That if we did that with teachers, and we did that well, it would impact the quality of their learners, their instruction or their teaching and their learners' learning. And we ran a quantitative study called a learning gain study. I don't have time to go into the detail. I'd be happy to take some questions afterwards. But we compared the learners. We did pre and post tests at the beginning of a year and the end of the year after teachers had completed the PD with us. We tested learners of teachers who'd been on the PD, and we matched these with comparison groups of learners whose teachers had not been on the PD. And the learners whose teachers had been with us performed significantly better. The gains were small, as is typical of this, and we started on a low base, but nevertheless, the gains were significant. And so we believe the project in this sense was successful. And these strategies that we have, these tasks of teaching that we worked and focused on were important. We have qualitative small-scale studies, small size, working in depth with a few teachers that have helped us illuminate how they work with exemplification and explanatory talk in lessons. We did some research on the lesson study that helps us actually fill out the step between the learner's performance on a test and the PD and what actually happens in the classrooms. And I hope through this I've been able to persuade you at least a little bit that exemplification through variation and working with specific language practices create or make available rich opportunities for learning mathematics. I always end with this because while I've presented this, it's not just my work. It's the work of a whole research team. So I thank them all. They will all see themselves in this. And we have new postdocs with us at the moment. You can only do this work if you're working in a large team. So thank you.
Thank you, Jill. This is a wonderful talk, and you have lots of responses in the chat, appreciative comments. I think those examples were quite illuminating. We have a couple of questions already in the chat box, which I'll...
Can I stop share, Ravi? Can I stop share?
Oh, yeah, sure. Unless perhaps you want to go back to some slide to explain.
Okay, so I'll leave it for now. Yeah, I'll leave it for now. Okay.
So let's go to the first question, which is from Jam, which was asked earlier about the difference between an example and an exercise. I think by exercise, you know, the things which come at the end of the unit or chapter. Yeah, that's. Would you like to say something about that?
Yes, that's a very good question, because actually in school mathematics, we normally refer to an example as the worked example. Okay, so if you look at a textbook, you'll have worked examples and then you'll have an exercise. The way we work with the notion of example is that what's in an exercise are examples, and the worked examples are different examples, and all of these would constitute the example set in a lesson. I hope that answers the question.
Yeah, and I suppose the word...
In some ways, the example sets that I showed could all be considered exercises, but exercises are often given after there's been some teaching. But here, these example sets actually could be used to do the teaching.
Yeah. And there's a related word that you use, which is of task and variations in the task. So would you want to say something about that as well?
Yes. So I didn't spend enough time on this. So when we vary the task, we would think about the variation in the task demand. So we would be looking at, is the task just expecting of learners something they already know? And we would call that a knowledge task. Or is it an application task, something that they've learned before? Or is it a more problem-solving task? So they have to, it's something less familiar, they have to actually think through. And so when we talk about task demand, we don't go into all the stuff on different kinds of tasks. There's a huge literature on that. We've worked more briefly, we've actually spent much more time on the example set than on the task per se. When we work with learner participation, which I didn't focus on today, then we would talk quite deliberately with teachers about the nature of the task and the task demands. I slid over that a little bit today. Okay, but if you go back to the lesson study where I said we changed the task demand, inserting the brackets, working backwards, is not a routine task. Okay, you have to think completely differently from applying the property to actually figuring out how is the property at work here and how can I make it work. You have to do a number of steps. You will still be using the property, but undoing and putting in the brackets is a much more demanding task.
Yeah, I think there's a hand from Suchi Smita. If it's a related question, we'll take it. Otherwise, we'll hold Suchi. Because there's some other questions in the line. Okay, so let me go to the next question, which is from Mani. I think this is a comment or possibly a question about the different meanings of the minus sign, the operator meaning, and the indication of a negative integer. And I think the question reads, I'm not very sure if it's clear. It says L1 is about the bigger signature. Why impose restrictions on the interpretation of operation symbols, especially when such restrictions are not typically imposed? Yeah, that's the question. I think it's, is it clear to you, Jill? I mean, it's probably about...
No, can you help? Can you decode it a bit for me?
I think it's, the question is perhaps about whether one needs to make these distinctions sharply between operator sign and the sign of the negative number.
Okay.
Whether one should be fluid. I think, I hope I've got it right.
Okay. Yes, I think that's an excellent question. So I would say ultimately you have to be fluid. If you work or I work, we move fluidly between operation and sign. But when children are learning this in the beginning, they conflate them. And so actually naming them for what they are and with their meanings as they're beginning to learn these is crucial, I would argue, but it must lead to fluidity. Whether we then, I have to work very hard to not say minus, 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 because as I'm doing it, I am flexibly moving between operation and sign. But this is not automatic, it's not spontaneous thinking. And so our work has certainly shown in that the teaching and learning of integers is very problematic in our schools. There are multiple errors that remain and then disrupt the learning of algebra. And one of the issues that we've worked with that we think has had an impact is when these distinctions are made in the initial learning, that we're not talking about the operation, we're talking about the direction of the number. Okay, now in different systems, I know like in the UK, they don't write, they write it as a directed number. I don't know if they still do, but certainly when I worked there a little bit, you would have the negative at the top. So it would be written the sign would be there as a directed number, and the operation would be as an operation in the expression. But that's not the case where we are. And so the conflation is there and it's problematic. We've seen the results of the problem. The goal is fluidity.
Thank you, Jill. I think the number of comments, which I'll skip. There's one more question. So as a teacher, is it a good practice to solve exercise questions for the students in the class or in the tutorials? So I guess the question is about explicit teaching of how to solve problems. What's your view on that?
Okay, so being explicit about the principles doesn't mean you teach everything. Okay, so these example sets that I gave, you don't do the examples one by one for the learners. You give the learner the whole example set. You get them to work on the whole example set and then you talk about them. What you are explicit about are the words we're using, are the ways we argue about which equation is true. Why do these equations have one result? There is a value that makes these equations true. But these equations are different. We don't get a solution. We'd end up with things like 0 equals 0. What kind of equations are these? That's what you're explicit about, not about doing the steps.
Okay, yeah, thanks. I think this, so what would be the criteria by which we sequence examples, especially in a language responsive manner? So are there some criteria for sequencing, I think, as opposed to just variation?
That's a very good question. And the answer is we haven't paid enough attention for me to be able to answer that clearly. But it's something to think about. Thank you for that question.
Okay, I think the question was from Ramanujam and the earlier question was from Cedrico Chase.
Oh, sorry, Ravi. Let me just go back to the language practice. I want to go back to the language practice of explanatory communication. So if you saw the 4 examples that I gave up, the way the teachers would do it, so you can test a case, you can relate it to an everyday analogy or a metaphor. And so we've had a lot of discussions about, well, do you start in the everyday and then lead to the formal and full explanation? And I would say that both extremes are problematic. We wouldn't want to start and stay with only specific cases or explanations that are only linked to everyday realities. We would want to be able to move towards mathematical explanations. Similarly, we could, and some teachers work from a full mathematical explanation, but then they fill it out with everyday examples. So that's a fluid movement. And I wouldn't say there's a sequence. You start in the informal and you land up at the formal. The formal is the end game. At the end, you want learners to be able to speak mathematical discourse. You want them to be participants in mathematical discourse. But the journey there is not linear. It's not one directional from informal to formal. It's a backward and forward movement of meaning making. I hope that answers the question.
I think that's, hope so. There are a few questions and we are now at 6:30 Indian time. Jill, would you be okay with taking maybe
sure.
Last one or perhaps...
A few more would be fine, Ravi.
Okay, Jill, yeah. So there's a question from Vinay Nair, where most of the students able to handle questions in the reverse way that Linda had suggested, which is placing the parenthesis task, I think. And were they more motivated to solve these problems more than routine problems of arriving at the answer from the question?
That's a great question. So what happened in the lesson is the learners nearly revolted. I mean, they were saying, we've never seen these before. We don't know how to do these. And in classrooms where everything has happened in the one direction, this was a complete shock. And so the teacher did have to mediate it. So he did have to demonstrate, well, let's do one simple one together. He had to do that on his feet. He fluffed while he was doing that. He found that quite difficult, which was really interesting for us. And we had a very interesting reflection at the end of the lesson about what does it mean to start working with doing and undoing. And one of the things that one of the teachers undertook to do, and we didn't follow it up any further, was that in a lesson like that, it might have helped if there'd been some doing and undoing tasks right at the beginning with the numerical expressions, where they were still familiar with the numbers and they could have made more sense of the numbers. That if we'd have done the doing and undoing task then the algebraic one later might have been easier for them to do. Some of the learners got it, but few, and most of them said it's too hard. We don't know what to do. Help us. We don't know what to do. And so, yes, it's a struggle to change how they think about that. But they did enjoy the challenge of it. And certainly the teachers learned a great deal about what it might mean to sequence that in if you're wanting to push learners to do those kinds of tasks.
Okay. Suchi has a question. Suchi, can you unmute yourself? I'm not sure whether you're able to. Okay, I think now you should be able to.
Yeah, thanks. I can. So actually a kind of related question was about task design. Vis-a-vis students who are of different attainment levels. I mean, I don't want to kind of, label or anything, but it is a fact that in a class there are students of different attainment levels. So when you were talking about how, you give them a task and they discuss in a group and then they they decide which is the best explanation and that goes up on a poster. So I was thinking, does that not mean that mostly high attainers get their explanations put up on the poster? And and other, like when you design the tasks, how do you kind of design it so that, it would kind of interest or motivate all the students? And how you form those groups also. Yeah.
Okay, so the task that I showed you where they put the posters up, those were teachers, those were not students, okay? Those were teachers in a professional development course. And we thought very hard about this. But we do think teachers are professionals and it's possible to respectfully discuss different ways of thinking. So if I want to bring that into a school classroom, I think what I would be doing is actually, and that's why it's interesting that we had the word wrong there. I would be wanting to work much more deliberately with the notion that as we're learning new things, we make errors. That's what mathematics is. Mathematicians start new things, they go down paths, they have to backtrack because it didn't lead them where they wanted it to go. So working with new ideas, it's quite likely that people will think differently. And we need to understand why they're thinking like that to make sense of it and then be able to move forward. So in that example that I gave you when we were working with teachers, it is about working with respectfully with teachers. So we worked, and when I say we had arguments, you understand their positions of power and knowledge and all of those things. But it was to take cognizance of the fact that teachers are doing things in their classroom that make sense. They're working with strategies in their classrooms that are successful for them. And we need to be able to talk about those and figure out, well, are these creating some of the problems later on that maybe they're not aware of? If we think about this in a different way, does it help you think differently about this? So it's not about being wrong and not knowing and creating people as in deficit. But it's very important how you as the teacher or teacher educator manages those sessions. So I think any classroom there is diversity. And if we're going to be able to work publicly with thinking, we have to be able to work publicly with error or with different ways of thinking. And we need to work on how do we do that respectfully.
Thank you, Jill. I think that's, the audience is sort of warming up and there are more questions coming, but we'll have to stop sometime. And perhaps we could compile these questions and, send them to you over by email. There's a couple of people who asked something about, using real life context in teaching,
yes.
Particularly in the context of maybe negative integers or other topics. Would you have something to say about that?
Yes. So what I wanted to say about context specificity. So our curriculum here does emphasize the importance of connecting with learners' realities. And so working from everyday problems and or problem set in everyday and real life contexts. Now that really starts to demand modeling skills of the teacher and being able to use representations in fluent ways, depending at what level you're working with. And working with different representations and real life representations is, of course, very important. When it comes to things like integers and negative numbers, some things work and some things don't. I mean, we cannot show a real life example of why -2 times -2 is +4. It just doesn't exist in the real world, it exists in the mathematical world. So, maybe we can have a good discussion about what representations and what kinds of things you would do to bring that and to create some meaning structure that's linked to other mathematical ideas and things that learners know, but trying to do it with temperature or with other things, it's fine for addition and subtraction. It runs out when we're working with multiplication. And so what do we do then? And what are the metaphors we might use? And what metaphors if we use? So the metaphor or the way of talking that's used is a minus and a minus makes a plus. Everybody would reckon 2 minuses make a plus. Well, if you've seen the overgeneralization, if you haven't seen the overgeneralizations of that, then I don't think you've taught in a lower secondary school. Because it's everywhere. It's everywhere. Now, that's because you're not reading the students are not reading the symbols carefully. They're not reading the distinction between the symbol and the sign and the operation. And so I don't know how you fix that with a real life example. So what are the other ways that you connect to make meaning? And Ravi can do that much better than me. With the representations on integers, he's done wonderful work on that.
Yeah, thanks, Jill. I think we probably stop now. Is that okay? There are many more questions, but I think we will probably take them on the email. And I believe the questions are being collected, so we can send them to you. And if you have any responses, perhaps we can post them at some convenient place. It was a wonderful talk. I think our teachers and the others in the audience gained much from it. And thank you so much, Jill. It's a wealth of experience that you bring. And I must mention that your project has been really inspiring for some of us. Working closely with schools, tracking change in teachers, change in teaching, as well as in learners. And it's been really inspiring. Thank you so much, and hope we have an occasion to have you sometime.
Thank you. Thank you. I'd hope to be able to listen to some things tomorrow. I'm particularly interested in the panels. One of them is far too early for me, But I really had planned to be online, but I might not make it. But I'm very interested to hear how teachers in India are dealing with the realities of our lives these days, and what it means to teach and learn in school at the moment. So have a wonderful conference, and thank you again for the invitation.
Thank you, Jill. Thank you. And
thanks, Ravi.
Yeah. Over to Harita.
Thank you.
Yeah. So if you want to say anything before concluding, otherwise we conclude this session, I think.
Yeah, Amber sir is actually.
Amber is there? Okay. Yeah. Over to you, Amber.
Okay. Yeah. Thanks everyone for being with us. Thank you, Ravi, for chairing this session. It was really quite interesting. And as a university teacher, I'm always wondering, we at university level hardly think about issues in this depth, and so much more happens at school level. And that's one of the bits of communication that one is hoping will happen as we talk to and listen to each other. Okay, so just a reminder that tomorrow the first session is at 10:30. That's the panel discussion, for the teachers' voices, for the school teachers. Look forward to seeing you then.
If you have any questions, you can write to the conference ID, and see you tomorrow. Bye.
Maybe you can leave the session open for 5 minutes if anyone wants to type in a question. Yeah. Otherwise, I suppose we can leave. Yeah.
Meenu ma'am, you already received an email. If you haven't, you can write to me on conference email ID. I will send it to you.